As early as 300 BC, sunlight was concentrated to start fires for cooking and warmth. Not until 1839 was it discovered that concentrating the sun's rays onto certain materials would generate an electrical charge. Electricity converted from the sun's light became known as photovoltaic or PV energy. Following the discovery of PV energy, scientists experimented with technologies and materials for more than a century. In 1958, a small array of solar cells provided enough energy to power the radio on a satellite bound for outer space. In the 1970s, PV panels began supplying electricity to offshore oil drilling platforms, telephone relay stations, and railroad crossing signals. Solar energy research is ongoing. Advances in technology and materials continue to increase the amount of electricity that a solar cell can generate and reduce the costs related to generating electricity from the sun's rays. When identifying a potential solar farm site, land availability, zoning, regulations, the existing and future use of the surrounding area, and the proximity to transmission lines must be considered. The location must be evaluated with regard to the amount of unobstructed sunlight it receives, and the site must be large enough to keep PV panels from shading other panels, regardless of the sun's location throughout the day. Soil studies and seismic reports help developers evaluate conditions and risks that could affect the farm's output and long-term maintenance costs. In order to deliver power to customers, a site's location in proximity to a viable power grid connection is critical and also affects the plant's construction and operation costs. PV technology uses solar cells to convert sunlight into electricity. At its most basic, electricity is the organized flow of atomic particles called electrons. Carefully crafted materials called semiconductors can be adapted to release electrons from their atoms when they're exposed to light. PV cells have at least two semiconductor layers, one negatively charged, the N-type layer, and one positively charged, the P-type layer. An electrical contact point is attached to each layer. Material at the junction of the semiconductors allows electrons to pass between layers, but only in one direction. When a wire is attached to the top and bottom electrical contacts, an electrical circuit is formed, allowing the electrons to flow, thus creating electricity. Sunlight contains particles of energy called photons that are absorbed by the N-type semiconductor. Their energy dislodges electrons that then flow through the electrical circuit, providing electrical energy. The semiconductors in PV cells are most commonly made from silicon, an element found in sand and other sources. PV technologies are broadly categorized as either crystalline or thin film. Crystalline silicon cells are manufactured by cutting narrow wafers from a solid block of semiconductor material. During the manufacture of thin film cells, semiconductor material is directly deposited onto a rigid or flexible, low-cost substrate. One solar cell can generate only a very small amount of electricity, typically less than 3 watts, which is roughly equivalent to the output of a AA battery. To increase electrical output, several PV cells are connected, grouped, and sandwiched within a frame between other materials to create a solar module. Solar modules are linked together to form a solar array. The arrays are then precisely positioned to absorb the most sunlight. In some installations, the arrays tilt and rotate to follow the sun as it moves across the sky. Row upon row of solar arrays are the most visible part of a solar farm. Solar cells within each array absorb the sun's light and convert it into electricity. Other components of the solar farm make the power usable to end-use customers. Before the electricity can leave the solar farm, it must pass through a power inverter or conditioner. This device changes the direct current coming from the solar cells into alternating current that is used by the motors, lights, and appliances it will power. After being converted to alternating current, the electricity travels to a step-up transformer. Within the transformer, the voltage is increased before it's sent through the power grid to homes and businesses. Solar energy is a non-polluting and renewable resource. Solar energy refers to the electrical power that can be generated from the sun's light. The more constant the sun's light, the more electricity that can be generated from it. From calculators to emergency telephones, traffic signs, parking meters, homeowner rooftop systems, and large power plants, the useful application of the clean, safe, sustainable power of the sun has become a part of everyday life. The Earth's natural resources must continue to be respected, and care always must be taken when balancing the potential environmental impacts of using these resources with the energy needs of current and future generations.